Alright, hello my Anur BF class. Ayan, so good morning, good evening, good afternoon. So in whatever time you are watching this video, yes. So for this video, we will be discussing microscopic analysis. So of course, this will serve as a complementary material to what you have already finished in your lecture. Okay, ayan po. So, yes, without further ado, let's start with your microscopic analysis. So from the term itself, microscopic analysis, okay? So we have to review what we have already discussed about your microscopes. Ayan, so that syempre ma-refresh ang ating mga utak. Ano-ano na ulit yung mga microscopes na pwede nating gamitin in your clinical microscopy section. Ayan, so ilabas na po natin lahat ng ating mga nalalaman kung meron man, okay, sa ating mga microscopes. Ayan, medyo naririnig-rinig ko na kayo. Yes, naririnig kita. Ayan, sana naman meron kang natandaan. Okay, from our first grading discussion. Okay, so una, ayan, ilabas natin ang bright field microscope. Okay, so again, what is the use of our bright field microscope in the clinical microscopy section? It is the one that we utilize for routine urinalysis. Okay, so ibig pong sabihin, it is the commonly available, siya yung nandyan na. Okay, kaya yun yung ginagamit natin for routine urinalysis. Okay, so take note lang po that whenever we utilize your bright field microscope in the microscopic analysis of your urine samples, we have to make use of subdued light. Okay? Ma'am, ano ang ibig sabihin ng subdued light? So pag sinabi po nating subdued light, dapat po hindi masyadong bright. Okay? We have to regulate the light intensity that we utilize whenever we use our bright field microscope for routine microscopic urinalysis. Okay? So yan. So if you can still remember, diba? If you can still remember po, during your face-to-face, I hope lahat naman po kayo ay nakapag-experience or naka-experience gamitin ang ating mga microscopes. Diba? Doon sa base portion ng ating microscope, meron tayong component doon that we can actually manipulate in order for us to select or to pick the right light intensity to be utilized for microscopy. And that particular component or part of your microscope is referred to as your rheostat. Okay, yan. So karagdagan lang pong explanation bakit subdued light ang kailangan natin. So take note na ang ating mga urine sediments, katulad nga ng lagi kong sinasabi, medyo mahirap po silang i-identify. Medyo mahirap po silang makita. Okay, using your bright field microscope. Bakit sila mahirap makita? Kasi they have low refractive indices. They have refractive indices which is almost similar to your urine. Ayan. So kung halos parehas sila ng urine, ng urine sample mo, 'di ba? Minsan wala kang makita. Okay, minsan walang makita or minsan mahirap silang makita lalo na pag too bright yung gagamitin nating light intensity. Kaya babaan mo. Huwag masyadong bright. Okay? Kasi nakakasilaw. Hindi, masisilaw ka, hindi mo makikita yung mga sediments natin. Alright? So that's why you have to make use of subdued light. And again, the component, we have your rheostat. Okay? So apart from, of course, our bright field microscope, another microscope that we can make use in the clinical microscopy section provided that it is available is your phase contrast. Ayan. So we have your phase contrast microscope. So in particular, your phase contrast microscope will allow us, okay, to make it easier to identify or to see sediments that have low refractive indices. So what are examples of sediments which have low refractive indices? So first, we have your hyaline casts. Okay, we have your hyaline casts. Another, we also have your mucus threads. So ito yung mga examples ng sediments na merong low refractive indices. That's why kung ang gamit natin in the laboratory is your bright field microscope, mahihirapan ka talagang makita sila. Okay? Kaya nga, kung available siya in the laboratory, might as well make use of your phase contrast microscope. So how does your phase contrast microscope allow us, okay, to easily identify sediments that have low refractive indices? So take note, nabanggit ko na din ito during our first grading period doon sa activity number 1. Diba? Okay, di ba? Yung ating phase contrast microscope, kung titignan mo yung mga sediments under this, meron silang tinatawag na halo. Okay? So this halo effect, okay, that is seen in the borders, in the perimeters of your sediments will make it easier na makita natin tong mga sediments na to. Okay, like for example, yung ating epithelial cells. So kung titignan mo yung borders ng epithelial cells natin, medyo, meron siyang halo. So it has a lighter, okay, it provides a lighter perimeter or lighter image on the borders of your sediments. Yun yung tinatawag nating halo. Okay, yes, that surrounds your sediments. And we are able to see this using your phase contrast microscope. Okay, ayan. So yun yung difference niya as compared to your bright field. Yung bright field kasi walang halo effect. Yung ating phase contrast microscope nagkakaroon ng halo effect. That's why makikita talaga natin easier as compared to your bright field microscope. Okay, so another microscope that we can use in the clinical microscopy section is of course your polarizing microscope. So again, anong substance na naman ang easily identifiable under your polarizing microscope? So we have your cholesterol. Okay, so any sediment that contains cholesterol will be easily identified using your polarizing microscope. So what are sediments na pwedeng merong cholesterol? So of course, we have your fat droplets, di ba? Yan, Okay, so of course, we have your fat droplets. Yan, pwede po silang merong cholesterol. What else? We have your oval fat bodies. So, may cholesterol din po yan. Ano pa? We have your fatty casts. Meron din pong cholesterol yan. Okay? So, under your polarizing microscope, your cholesterol will have a characteristic appearance. And again, what is the characteristic appearance of your cholesterol under your polarizing microscope? So, we have your Maltese cross formation. Okay? So, yan yung characteristic appearance natin. So, or ng cholesterol rather. So kung yung fat droplets mo, yung oval fat bodies mo, yung fatty casts mo ay merong cholesterol, magkakaroon din sila ng tinatawag natin na Maltese cross formation. Okay, yes, demonstrable under your polarizing microscope. Okay, so in addition to these three microscopes, so pwede din po nating gamitin si dark field. Okay, so we have your dark field microscope. So just put an asterisk on your dark field microscope because, yan, ano na ulit yung sample natin na ginagamit natin for your dark field microscopy. So we have your CSF. Ma'am, bakit CSF ang ginagamit? Kasi para saan ba si dark field microscope? So take note that your dark field microscope is utilized for the demonstration of your treponemes or your spirochetes. Okay, so in particular, we are after the demonstration of the causative agent of syphilis, which is your Treponema pallidum. Okay, so take note also na ang treponemes natin or ang ating spirochetes, particularly we have your Treponema pallidum, it is demonstrable only in your cerebrospinal fluid. Kaya nga sabi ko, you have to put an asterisk on your dark field microscope kasi we are not talking about your urine sample here. We are talking about your cerebrospinal fluid in which we are able to demonstrate your treponemes or your spirochetes. Okay? So another microscope that we can use in this section, we have your fluorescent. Okay, we have your fluorescent microscope. All right. So your fluorescent microscope allows us to detect the presence of naturally fluorescent. So ibig sabihin, even without your tags or your labels, makikita mo pa din sila under your fluorescent microscope. Okay? So we have your naturally fluorescent sediments or sediments which have been tagged, okay, or labeled. Ayan. So when it comes to the tagging or the labeling of your sediments, the substance that we use, we refer to it or to them as your fluorophores. Okay, so ang tawag po natin sa kanila ay fluorophores or your fluorochromes. Okay, so these are basically the tags or the labels that we use in order to demonstrate your sediments. Yes, in order to demonstrate your sediments under your fluorescent microscope. Okay, so we have your fluorescent microscope. All right, and then the last one. Yes, the last one, we have your interference microscope. Okay, so take note that your interference microscopy, this is otherwise referred to as your layer by layer imaging. Okay, so layer by layer imaging, which allows us to produce or to provide a three-dimensional, okay, so three-dimensional image as compared to the two-dimensional image provided by the other microscope. So that is what makes your interference contrast microscope unique, okay, and different from the other microscopes. So hindi lang 2D, hindi two-dimensional ang provide niyang image. Ang provide po niyang image ay three-dimensional, okay? So take note also that there are two interference microscopes that may be available in the laboratory. So the first one, we have your Hofmann. Okay, so we have your Hofmann. Diba sabi ko, you have to underline letter M or you have to capitalize letter M. Why? In order for you to easily remember that the mechanism that is involved for your Hofmann interference microscope is your modulation. Okay, modulation contrast. All right. And then the other interference microscope, we have your Nomarski. Okay, so your Nomarski, ang ika-capital naman po natin dyan or ang ating underline ay yung letter R. So, letter I. O sige, pwede ding letter R. Okay, letter R or letter I. Why? Because the specific mechanism that is involved in your Nomarski microscope is differential. Okay, so we have differential interference contrast. Interference contrast. So that's why in some of the books or the references that we have, your Okay, your Nomarski is otherwise referred to as your DIC. Yan. So, differential interference contrast. Okay, we have your Nomarski. Alright, so I hope na-refresh with matching laking mata. Okay, na-refresh ang ating mga nalalaman when it comes to our microscopes. Okay, yes. So, let's move on to the next slide. Ayan, next po natin. Okay, sige. Itanggal ko lang yan lahat. Alright. So, bago po tayo pumunta sa mga sediment stains, okay, before we go to your sediment stains, of course, we have to discuss how do we prepare your sample for microscopic analysis. Sorry. How do we prepare your sample for microscopic analysis? So, there is actually a general procedure, okay? General procedure that we perform in the laboratory bago po tayo makapag-perform ng microscopic analysis. Number 1, you have to check the specimen. Okay? What are the 2 things that we have to check for your specimen? So first, we have to check the specimen integrity. Okay? And then, of course, we have to check specimen adequacy. Oh, magkaiba po yan, class, ha? Ayan. So, pag sinabi nating specimen integrity, may integrity ka ba? Okay. May integrity ba yung specimen mo? Ibig sabihin, acceptable pa ba yung specimen natin? Okay, for us to perform your microscopic analysis. Ayan. So, when it comes to specimen integrity, we are after the freshness. Oh, fresh ka pa ba? I hope fresh pa po tayong lahat. Ayan. Fresh pa ba yung specimen natin? Remember, okay? Ano ang recommended na specimen natin for microscopic analysis and in general for routine urinalysis? Sige, lagay natin yan. Lagay po natin yan. Okay, ano ang recommended ba na specimen? Ang recommended na specimen ay fresh. Okay? Fresh specimen. Alright? So, ibig sabihin, no preservative added. Okay? And of course, it has to be midstream, via midstream collection. So, ilagay ko lang ha, no preservatives added. Okay? And it should be collected via your midstream. Okay, lagay ko lang ha, midstream collection. Ayan. So yan. Yan ang requirements when it comes to the collection of your specimen. Dapat fresh. Okay, ibig sabihin no preservatives added. And another, you also have to instruct your patient na dapat it should be dapat midstream collection siya. Okay, so yan. Ma'am, when it comes to freshness, okay, when it comes to freshness, ayan, ng ating mga specimens, there is a recommended time. Ayan. Na sinasabi yung ating mga references for you to have already finished your analysis. Okay? So, ang sabi po ng ating mga references, urinalysis, okay? Urinalysis should be performed within 2 hours. Okay? Within 2 hours after collection. Ayan. So, within 2 hours after collection, ibig sabihin, doon sa 2 hours na yan, kasali na yung pag-submit sa laboratory, kasali na dyan yung analysis na ipaperform mo. So, ibig pong sabihin, kasali doon sa analysis ang physical examination, yung chemical examination, at saka yung microscopic examination. Okay, so that's why in the laboratory class or in practice, ano ang sinasabi natin sa ating mga pasyente? Ma'am, sir, you have to submit. Okay, sige, lagay ko ha, submission. Yes, you have to submit your urine sample within 1 hour. 1 hours. 1 hour. Okay? O, wag babalik-tarin or pag-iisahin ang submission sa examination. Okay? Ilagay ko lang dito para hindi na tayo malito. Okay. Ayan. Pag sinabi nating submission within 1 hour, yung natitirang 1 hour po class, para na yan sa examination mo. Okay? Kaya, ang sinasabi natin sa mga pasyente, ma'am, sir, you have to submit within 1 hour after collection. Okay? To give you time. Oo, 2 hours. Pero, dapat may time kang ibibigay doon sa medtech na i-perform yung examinations. At ano yung time na yan? 1 hour. 'Di ba? Okay. So, class, para at least mas maintindihan natin, kunwari, may isang pasyente. Okay? Para mas maintindihan natin yung examined within 2 hours, submitted within 1 hour. Ayan, may isang pasyente. Kunwari, nag-submit siya ng sample 1 hour and 30 minutes after niyang makolek. Tatanggapin mo pa ba yon sa laboratory? Tatanggapin mo pa ba? Hindi na. Bakit? Kasi you only have 30 minutes to perform the examination. Okay? Hindi naman agad-agad na yung sample na yan ang UUA mo, ang urinalysis mo. 'Di ba? Nakapila yung mga samples na yan. So ibig sabihin, okay, 30 minutes na lang ang natitira para you are able to provide a reliable examination of the sample. Enough ba yung 30 minutes? Okay? Yun yung problema kasi doon. Kaya as much as possible, hindi. Ang talagang sinasabi natin sa mga pasyente ay within 1 hour to give you time to perform the examination. Kasi after 2 hours, what will happen to your sample? Your sample is no longer acceptable. Why? Because the cells, the casts, and the other sediments which are present in your urine sample will start to disintegrate. Yung mga cells natin, magla-lyse na yung mga yan. Yung ibang sediments, magdi-disintegrate na yung mga yan. Okay? And so, acceptable pa ba yung specimen? Hindi na. Okay? It is no longer acceptable because you will no longer provide a reliable result for your specimen. So that's why submission within 1 hour. Examination within 2 hours. Otherwise, hindi na acceptable yung urine sample natin. Okay? Ma'am, di ba may refrigeration naman? Okay, ayan. Very good question po sa mga nakapag-isip ng question na yan. Oo, tama. Meron tayong physical method of preserving your urine sample and that is your refrigeration. Tama. Yes, tama. Very nice question. Okay. Napakamot ulit-tuloy ako ng ulo. Okay. Bakit hindi natin nire-recommend ang refrigeration? Okay? Why? Because take note, class. Okay? Take note that although, yes, sige, tanggapin natin, although your refrigeration prevents, yes, it actually prevents lysis or disintegration. Tama? Yes, it prevents lysis or disintegration of your urine sediments. However, may but dyan. Ayan, but. However, take note that there will be an increase. Okay? Refrigeration actually promotes an increase, but an increase, okay, in the precipitation. Okay? Precipitation of of amorphous and crystalline materials, okay, is noted or is noted or observed. Okay? So yan. Refrigeration, yes, oo naman. Accepted yan. Yes, tanggapin natin. It prevents lysis or disintegration of your cells and of the other sediments. But, okay, there will be an increase in the precipitation of amorphous and crystalline materials. Okay, so that means ideally, hindi pa din siya okay na i-refrigerate mo. Naku ha, hindi pa rin siya okay. Between a refrigerated specimen and a fresh specimen, alin ang mas maganda? Yung fresh, syempre. Okay, naku ha, kaya nga ang nilagay ko dyan, recommended ay fresh pa din. Alright, no preservatives added, no preservation as much as possible, and it should be collected via midstream collection. Okay, so yan. So hopefully hopefully, ang haba naman ng ating Okay, hopefully, yan, naintindihan po natin itong part na to. Okay, so yan. Alright. So apart from the integrity, okay, sabi ko dyan, integrity, specimen integrity, we also have to check the adequacy of your specimen. Okay, so yan. So tanggalin ko na yan ha. Okay. Alright, so punta na tayo doon sa pangalawa. We have your specimen adequacy. So ano ang ibig sabihin ng specimen adequacy? Enough ba? Okay, enough ba yung specimen natin? Sufficient ba? Sufficient. Sufficient ba yung specimen natin? Adequate ba yung specimen natin? So when it comes to specimen adequacy, ano ang tinitignan natin? We are taking into consideration your specimen, okay? Specimen volume. Alright. So for routine urinalysis, the required specimen volume is 10 to 15 ml. Okay? Particularly, pag magpa-perform ka ng microscopic analysis, dapat meron kang 10 to 15 ml ng urine sample or an average of 12 ml. Kaya nga, if you are going to go back to the video that we provided, me and Sir Ruben, okay, di ba, gumamit pa kami ng centrifuge tube in order to show you na dapat ang urine sample na gagamitin natin, particularly for microscopic examination, is 12 ml. Okay, ma'am, paano pag kulang yung sinubmit ng pasyente? I-reject mo. Because that is one of the general procedures that we perform in the laboratory in order for us also to provide a reliable result. So pag kulang yung volume, you reject kasi hindi siya adequate, hindi siya enough, hindi siya sufficient for your microscopic analysis in particular. Okay, so again, 12 ml po ha, that's an average. So 10 to 15 ml or an average of 12 ml. Ngayon, in the exam, paano kung given lahat? 10, 11, 12, 13, 14, 15. Okay, and then walang all of the above. The best answer is 12 ml because that's the average. Okay, so yon. So specimen adequacy, again, dapat po ay 10 to 15 ml or an average of 12 ml. Okay, so yan. So, na-check na po natin na okay ang integrity ng specimen. Okay? Okay ang volume ng ating specimen. The next general procedure that you have to perform is, of course, your macroscopic examination. Okay? So ito po ang sinasabi sa atin ng ating mga references. So you have to perform macroscopic examination before you proceed to your microscopic examination. Okay? So ilagay ko lang, ito ang theoretical. Theoretical kasi ito yung sinasabi ng ating mga libro. Okay? Pero in practice, ang ginagawa po natin is we perform macroscopic. Okay? We perform macroscopic examination plus your chemical examination. Ito ang ginagawa natin in practice. Okay? In practice. Ayan. So may I just explain po. So remember, ang daming remember. Okay? So tandaan po natin. Pag magpa-perform ka ng microscopic analysis, ise-centrifuge mo, and then what do you do with the supernatant doon sa fluid na na-form above your sediment? Ano ang ginagawa natin? Dinedecant. In short, tinatapon natin. Okay? Paano kung kunwari hindi mo pinerform si macroscopic at saka si chemical? And then eksakto na 12 ml lang yung sinubmit ng patient natin in the laboratory. O di ba? Natapon na, na-decant na yung supernatant which you are supposed to subject to macroscopic and chemical examination. Okay, tama. So that's why in practice, ang ginagawa po natin is we perform macroscopic, we perform chemical examination before we proceed to your microscopic examination kasi yun ang practical na gawin sa laboratory. Okay, nakuha? Ayan. And apart from that class, there are also certain parameters, yes, certain urine characteristics which you need in order to correlate, to the possible sediments which may be present in your urine sample. Alright, example, alam ko, nabanggit ito ni Sir Ruben doon sa kanyang video. Example, color. Okay, saan magpo-fall ang color? Macroscopic examination, physical examination. Tama? Ang color niya red. Okay? So ikaw, bilang medical technologist doon sa laboratory, what are sediments that would correlate to a red color? Yes, very good. Red blood cells. Tama? Okay. Another, turbidity. Nung in-examine mo siya macroscopically or physically, ano ang nakita mo? Turbid yung sample. Okay? So ano yung ine-expect natin na possible cause ng turbidity? So we have your sediments. Okay, we have your epithelial cells, we have your mucous threads, we have your white blood cells, we have your bacteria, we have your yeasts. Tama. Yan, mga causes yan ng turbidity. So again, bilang medical technologist, iisipin mo, baka merong ano ito. Okay? So yun yung ine-expect mo na makikita doon sa microscopic analysis natin. Alright? So another, punta naman tayo doon sa chemical examination or chemical examination or yung ating chemical parameters. Positive for your leukocyte esterase. O para saan ba ang leukocyte esterase? Para po yan sa detection ng WBCs in urine. O positive siya doon. Turbid yung sample mo. Ine-expect mo na meron kang makikitang WBCs under the microscope. Tama? Okay. Another, positive siya sa nitrite. Okay, turbid yung sample natin, homogeneous turbidity yung nakikita natin sa sample and then positive siya sa nitrite. Tama, bacteria. Nakuha? Ayan, red yung sample mo. Nag-positive siya doon sa blood parameter ng ating reagent strip. Ano ang ine-expect mo? RBCs. Okay, so yan. So it helps po na i-perform natin yung macroscopic examination at saka yung chemical examination because it will give us clues, okay, as to the different sediments which may be present in our urine sample. Nakuha, ayan. Kaya maganda na i-perform natin ang hindi lang macroscopic examination, kundi pati na ang chemical examination before we perform your microscopic examination. So, nandyan po sa ating module on page 78 o screening test. Okay, nandyan. Yan yung part na ine-explain ko, class. Okay, so yan. So those are the general procedures na kailangan nating i-perform before we go to your microscopic analysis. Okay, so yan. Next naman po tayo, class. How do we prepare? your specimen for microscopic examination. So again, specimen volume, 12 ml, average, 10 to 15 ml, yan yung range. Okay? So after that, you have to perform centrifugation. Alright, so ano yung required centrifugation technique natin based on the different references that we have in clinical microscopy. So you have to centrifugate your sample at 400 RCF for 5 minutes. Okay? So 400 RCF for 5 minutes. So dahil pinag-uusapan na natin ang centrifugation, okay? So balikan lang po natin when ang ating quality control for our centrifuge in the laboratory. So again, calibration. Okay? So sorry. Calibration. Ano ba? Ayan. Calibration of our centrifuge. Ano na ulit? Okay, very good. We have every 3 months or in other references, sabi nila, quarterly. So, kahit ano naman ang gamit mo dyan, every 3 months or quarterly, parehas lang po yan. Okay? So, how about when it comes to the disinfection of our centrifuge, ano po ang sabi nila? We have weekly. Okay? So you have to, yes, weekly. You have to disinfect your centrifuge weekly. Okay? So ano ang ginagamit natin for the disinfection of our centrifuge? Of course, we have your sodium hypochlorite or your bleach. Alright, so I have read also in one reference that instead of bleach, kunwari hindi masyadong mayaman ang ating laboratory, okay, at wala siyang bleach, pwede din pong gamitin ang vinegar. Okay, vinegar, pwede po siyang substitute bleach. Ayan. Kaya nga sabi ko nung punta ako sa grocery, ano ang difference ng vinegar sa bleach when it comes to the price? Halos parehas lang naman sila ng price. Pero anyway, yan, para lang po ma-share ko yung knowledge na syempre nabasa ko. Ayan, so pwede pong gamitin ang vinegar, okay, instead of your bleach. Ano bang ginagawa nyo sa laboratory? Mayroon kayong vinegar, wala kayong bleach. Ano ba yan? Okay. So anyway, yan po. Alright, so centrifugation. Ayan. So after centrifugation for 5 minutes, alright, so of course, you have to decant. Okay. Alam ko, dinemonstrate din ito ni Sir Ruben ng maayos doon sa ating video. Sabi nga niya, pag nagdecant ka, huwag kang matatakot. Okay? Basta itaob talaga. Basta ang gawin mo, okay, you decant. Ayan, you decant lang. Huwag kang matakot na mawala yung sediment. Kasi, kaya ka nga nag-centrifugate, di ba? What is the what is the reason for centrifugation? So that the sediments will be concentrated at the bottom at saka naka-adhere naman yung mga yan doon sa bottom natin. So do not be afraid when you decant. You just decant. Okay? Normally, naturally, mag-decant ka lang to remove the supernatant. Okay? And of course, what is left would be your sediment. Okay? So, when it comes to the volume of the sediment after decantation, nasa ano nyo po kasi yan, nasa module. Okay? So, volume of sediment after decantation. So, ano dapat? We have 0.5 to 1 ml. Okay? So we have 0.5 to 1 ml after decantation. And then from your 0.5 to 1 ml, of course, you have to mix it again, okay, para masuspend yung sediments doon sa natirang supernatant na very konti. Okay, so what is the required volume for examination? Okay, lagay ko lang ha, class ha. Volume for examination. Okay, volume for examination po natin ay 20 microliters. So yan yung ilalagay natin doon sa slide. So it has to be 20 microliters. Okay, syempre yung mga yung mga iba sa inyo baka nagtataka, ma'am, 20 microliters lang naman pala ang kailangan. Bakit 0.5 to 1 ml ang dapat na matira after decantation? Class. Okay, so in the event that you want to perform the microscopic examination again at nag-dry out na yung 20 microliters na nilagay mo doon sa slide, saan ka kukuha? 'Di ba? Saan ka kukuha kung eksaktong 20 microliters din lang ang matitira doon sa sediment mo after decantation? Tama? Okay, syempre dapat may plan B tayo, dapat may handa tayo. Oh, handa. Dapat lagi kang handa in whatever eventualities na pwedeng mangyari sa laboratory. Okay? Ayan. So although 20 microliters lang talaga ang kailangan mo sa examination, 20 microliters lang ang ilalagay natin dun sa slide, syempre may mga instances na kunwari may stat doon sa ibang sections ng laboratory at mag-isa mo lang na medtech, okay? Nailagay mo na yung 20 microliters pero hindi mo pa na-examine. Pagbalik mo, dry na yung 20 microliters. O, paano na yan? Diba? So, dapat meron ka pa ring extra, okay, na volume ng sediment na pwede mong i-analyze ulit microscopically, na pwede mong ilagay ulit doon sa slide. Nakuha? Kaya, dapat 0.5 to 1 ml pa din. Okay? And then, volume for examination, huwag kakalimutan, we have 20 microliters po. Alright, so those are the things that you have to remember when it comes to the preparation of your urine sediments. Okay, so yes, ready na ba tayong mag-examine? Yes, ready na tayong mag-examine. Pero there are some laboratories, okay, in which sediment stains are available. Okay, so ito din yung sediment stains natin. So ano-ano yung iba't ibang sediment stains that we can use in the laboratory? So I am currently looking at your module also. Okay, sige. May nabanggit po kasi dyan sa module natin na yes, examine. Yes, that's the next step. And then doon sa isang box nakalagay dyan ADIS count. Okay? So take note that your ADIS count, ito, we don't perform it in the laboratory anymore. But if you are going to trace the history of the microscopic examination of your urine sample, okay, ang pinakaunang pinerform as part of the microscopic evaluation of your urine is your ADIS count. Okay, so take note that your ADIS count, this is a quantitative measure of the different formed elements which are found in your urine sample. Ano ang specimen natin? We have your 12-hour urine, and then the preservative that is utilized is your formalin or your formaldehyde. Okay, and we are merely looking at certain populations or certain types of sediments. So if, for example, these sediments are present, okay, if these sediments are present in your urine, then it indicates renal disease. So in particular, if the number of your RBCs is 500,000, okay, greater than 500,000, then renal disease. Ibig sabihin, WBCs and your epithelial cells, okay, if they are present greater than 2 million, that's in your Strassinger. Okay, in one reference, ang nakalagay dyan sa module nyo ay 1,800. Okay, but in Strassinger, ang nakalagay po ay 2 million. So, I want us to follow 2 million. Okay, so greater than 2 million, so we have renal disease. So kung WBCs and epithelial cells greater than 2 million, renal disease. Okay, and then lastly, we have your hyaline casts. If they are present greater than 5,000, okay, greater than 5,000, again, it indicates renal disease. Okay, so yan. So in-explain ko lang po. Alright, so next we go to your sediment stains. Okay, so we go to your sediment stains. So there are, yes, there are 2, 4, 6 sediment stains that we can utilize in the laboratory. So lagyan nyo na lang ng asterisk si 2% acetic acid kasi it's not really a sediment stain, but it is a reagent that we can use to distinguish sediments which are present in your urine. So particularly yung mga cells natin. Okay, cells. Alright, so first we have your Sternheimer-Malbin. Okay, so your Sternheimer-Malbin, so this is composed of a combination of combination of dyes. We have your crystal violet and safranin O. Okay, so crystal violet and safranin O. And take note, ito yung commonly na ginagamit natin in the laboratory. Okay, so crystal violet plus your safranin O. Alright, so in particular, your Sternheimer-Malbin is utilized to provide coloration for your WBCs, your epithelial cells, and your casts. Okay, so another, we have your toluidine blue. So toluidine blue, so this enhances the nuclear details of your cells. So that's why it is utilized in particular to differentiate your WBC from your renal tubular epithelial cells or your RTE. Okay, and then next we have your lipid stains. In particular, we have your oil red O. Okay, so we have your lipid stains. In particular, we have your oil red O and your Sudan 3. Okay, so take note that the specific type of lipid that is demonstrable using these stains, we have your triglycerides. Okay, we have your TG na lang ilalagay ko ha. We have your triglycerides, otherwise referred to as your neutral fats. So with the use of oil red O and your Sudan 3, or rather your Sudan 3, your triglycerides or your neutral fats will have a characteristic orange-red color. Okay, so orange-red color po ang ating triglycerides at ang ating neutral fats. Alright, alright, so next we have your gram stain. So gram stain, this is utilized to determine the type of bacteria, yes, bacteria which causes your urinary tract infection. So whether the bacteria is gram positive or gram negative. Okay, and then lastly, bakit ba ako lastly? Okay, next we have your Hansel Stain. Okay, so we have your Hansel Stain. Your Hansel Stain, this is also a combination of stain or dye. In particular, the dyes that are incorporated in your Hansel Stain, we have your methylene blue plus your eosin Y. Okay, sounds familiar, di ba? Kasi in Hematology 1, okay, pag itatanong yan, stain that is composed of methylene blue plus your eosin Y, pag sa hematology yan, ang tawag natin dun sa stain ay right stain. Tama? Ayan, tama? Okay. Pero pag sa clinical microscopy yan itatanong, methylene blue plus eosin Y, ang tawag natin dyan ay Hansel Stain. Okay, so in particular, your Hansel Stain, so this is used to demonstrate the granules of urinary eosinophils. Okay, so for urinary eosinophil granules, we have your Hansel Stain. Paborito po nila ito sa board exam. So please let us be familiar with your Hansel Stain. Okay, so your urinary eosinophils, they are actually significant in cases of interstitial nephritis, okay, which is an inflammatory condition. So from your knowledge in immunology, alam natin na ang eosinophil, okay, they they participate in inflammatory conditions, or they participate in the process of inflammation. Okay, so interstitial nephritis, urinary eosinophils, and the granules are detected using your Hansel stain. Okay, and then last stain, we have your Prussian Blue. Okay, so your Prussian Blue, na-encounter natin to sa HEMA 1, na-encounter din po natin ito sa histopathology, or okay, your histotechniques. So take note, always class, wag niyong kakalimutan, kasi ang Prussian Blue, isa lang naman ang type ng substance ang kinocolor niya. So we have your iron. So in particular, we are after the demonstration of your hemosiderin, okay, hemosiderin granules. All right. So ano ang significance niyan in terms of your urine sample? Okay. So yan, meron na tayong HEMA 1, meron na tayong immunology. Punta naman tayo ngayon sa blood banking. Okay, so you will probably learn this in your blood banking when you go to the investigation workup that you have to perform in relation to the occurrence of your hemolytic transfusion reactions. Okay, isa sa mga samples natin sa investigation workup ng hemolytic transfusion reactions ay ang ating urine sample. So in particular, we collect your urine sample 1 week after your hemolytic transfusion reaction, and we are after the demonstration of your hemosiderin granules, which is associated with your intravascular hemolysis. Okay, so associated po siya, presence of your hemosiderin granules, it is associated with your intravascular hemolysis seen 1 week after your hemolytic transfusion reaction. Okay, so yan. So class, I will stop the video from this portion kasi ito naman yung introduction ng ating microscopic analysis. And then, of course, I will provide the additional videos for our sediments. Okay, so I hope you learned something from this discussion. Yes, I'll see you again. Ang bangs ko naghiwalay na. Alright, I'll see you again in the next video. Okay, bye! Bye!